Assalamu alaikum. Welcome to lecture number 8 of Software Design and Architecture. Before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, what we discussed in our last lecture, if you remember, we complete our topic unified modeling language. We also see a real world case study of automated teller machine, which we also known as ATM machine. We derive different software design specifications from ATM case study, and then we provide use cases, UML based different diagrams like sequence diagrams, class diagrams, context diagrams, subsystem based diagrams, and so on. We thoroughly discuss different UML based notations from this auto teller case study. Now, let's move the official discussion of our today's lecture. So, students, these are the objective of our today's lecture. First of all, we will see the architectural design, and we also see the who is actually responsible to develop the architectural design, and then we see the importance of software architecture design, and then we see try to differentiate between the design and architecture to get better idea about these terms, and then we see the different challenges being faced by that in the design phase, and then at the last we discuss the software architecture in context, actually how the software architecture comes from, and at the end we will see a real world case study on design error, where we see the Ariane 5 flight 501, how it causes a design error in the software. So here are the brief objectives of our today's lecture discussion. So let's start. So first of all, the software design. We briefly or comprehensively discuss this term in our first three lectures, if you remember, where we see the different design principles, where we see abstraction external to the decomposition, where we see the subsystem based, which we call the layer based, and the uh, tree based, and the layer based we also seen, and then we see the, if you remember, we see the different design principles in our first three lectures, where we see the abstraction external to decomposition, which we call the abstraction external to the system, which actually gives us the architecture. And we say abstraction external to the architecture, where we see three different kinds of decomposition, like subsystem based, which we call the horizontal decomposition, and the tree base, which we call the tree shaped, and we see the layer based decomposition, which we call the vertical. All of these three kinds of decompositions are basically abstraction external to the system, which actually gives us the architecture of our system. And then we see the abstraction internal to the system, which actually gives us the detailed design. And we see how abstraction internal to the modularization, where we see the two different terms, information hiding and encapsulation, which are basically two different techniques to achieve modularization. So till here we very comprehensively discuss the software design. So basically, the literature on design method began to appear in the late 60s. Then this design methodology became an independent discipline of software studies. So डिज़ाइन बेसिकली जो हमारे पास है डेवलपमेंट फेज़ का, डिज़ाइन बेसिकली हमारे पास डेवलपमेंट फेज़ का सेकंड फेज़ है, जो राइट आफ्टर द रिक्वायरमेंट फेज़ स्टार्ट होता है. सो बेसिकली डिज़ाइन इज़ अबाउट हाउ द सिस्टम विल परफॉर्म इट्स फंक्शंस. सो बेसिकली जो हमारे पास रिक्वायरमेंट फेज़ है, रिक्वायरमेंट एंड इंजीनियरिंग, इट इज़ बेसिकली अ प्रॉब्लम डोमेन, and the design phase is basically a solution domain. In the requirement phase, actually we tells us what the system will do, we will not focus on how the system will do. We will only focus how the system will perform its functions in the design phase only. So you can say that in the late 60s, design methods begin to appear in the software engineering field, and it becomes the scientific study as well. And design phase is the second phase of SDLC, right after the requirement analysis and gathering phase. And in the phase, actually we thinks about what the system will do, not about how the system will perform its functions. And the what part will be considered in the requirement phase, and how the system will perform its functions, and the how part will be considered in the design phase. So basically design software design is very different. Computer softwares are very difficult to design because there are multiple factors which can affect our designs with respect to different stakeholders. So students, what are the stakeholders? You can say that anybody who is directly or indirectly affected by the system, basically we call them stakeholders. So let's discuss the some example of stakeholder. Let's for example, I say a university management system. So what stakeholders can be in university management system? Like teachers, students, quality assurance team, all of these are stakeholders of university management system. So the specifically different people who actually participate in that design process, different people plays a different design process and influence the design of software. So basically what does it mean? It is actually saying that कि हमारे पास जो सॉफ्टवेयर डिज़ाइन का प्रोसेस है, इसके अंदर सॉफ्टवेयर डिज़ाइन के प्रोसेस के अंदर डिफरेंट स्टेक होल्डर्स इन्वॉल्व हैं, और हर स्टेक होल्डर डिज़ाइन प्रोसेस के अंदर डिज़ाइन को डिफरेंट वेज में इन्फ्लुएंस करते हैं. हाउ? लाइक डिफरेंट डिज़ाइन फेज में हमारे पास कौन कौन सी एक्टिविटीज़ हैं, लाइक आर्किटेक्चरल डिज़ाइन, interface design, component design. All of these are the different roles in the design process which actually influence the design of our software. So let's more simplify the software design term with some more detail. Basically you have to very well aware about the problem domain and the solution domain. Requirement engineering or requirement analysis or gathering is our problem domain, while the design phase is our solution domain. In the requirement phase, we actually say what the system will do. We will not focus on the how the system will perform its functions, while in the design phase we will only provide the solutions about how the system will perform its functions. So in short, we can say that the requirement engineering phase is about what the system will do, and the design phase provide us the solution how the system will perform its different functions. So in short, you can say that requirement analysis and gathering phase is about the problem domain, while the design phase, which comprises of the two other activities like architectural design and detail design, it is all about the solution domain. So basically design is actually about the how the system will perform its functions. So what type of functions it can be performed, like the decomposition of the system, how the decomposition is performed. As we discussed earlier, there are different kind of decompositions which we discussed in our first three lectures. Decomposition like subsystem based, which we also call the horizontal decomposition. We also see the tree based decomposition. We also discuss the layer based decomposition, which we call the vertical. Basically abstraction external to the system can be achieved by these three kind of decompositions. These three kind of decompositions are actually discussed in the design phase. I am not talking about the detail design or the architectural design. Here I am generally talking about the design phase, not specifically architectural design or the detail design. I am talking about the more abstract term, the design. Here we actually discuss the software design term in a general view, and then after provides the overall decomposition, we also split the work among the different team of developers, and then these team perform different tasks as well. And then we also discuss different non-functional requirements in the design phase as well. What are the non-functional requirements? Like different quality requirements of the system are called the non-functional requirements. Functional and non-functional requirements are discussed in the design phase. Basically, non-functional requirements are those requirements which are actually the quality requirements of the system, like performance, reliability, availability, maintainability, portability. All of these kinds of requirements are non-functional requirements. In further more detail, design phase is further divided into two broader categories: architectural design and detailed design. In the architectural design, we are concerned with the non-functional requirements only, which are the quality requirements of the system, while in the detailed design we also concern with the only functional requirements, which actually tells what kind of services the system will provide. And at the end, design phase will also concern with the technology as well, where we also need to discuss what kind of middlewares will be used, what kind of database design will be. So what are the middlewares? So basically, middlewares are the software that acts as a bridge between an operating system or database and applications, especially on a network. Some common middleware examples you can say that include database middlewares, application server middlewares, message oriented middlewares. So in short, different kind of middlewares are available. In the design phase, we are also concerned about the target technology which are going to being considered, like what kind of middleware will be used, what kind of database design will be used. So in this slide we briefly see the general term of software design. We are not discussing here the architectural design or the detailed design. We generally discuss the aspect of software design. In this slide we discuss the problem domain, which is basically a requirement phase, and the solution domain, which is actually concerned with the design phase. So what kind of design challenges are currently being faced? So students, our design should not do too much, it should not add too much detail, so it looks like or it gives us over a programming or implementation level code. So on the other hand, design team should not do too much little work. It is essential for the design team to produce a complete detailed design. So student, what does it mean? हमारा जो डिज़ाइन टीम है उनको बहुत ज़्यादा भी डिटेल्स ऐड नहीं करनी कि जो डिटेल डिज़ाइन है वो हमारा प्रोग्रामिंग कोड में कन्वर्ट हो जाए, और ना ही उन्हें डिटेल डिज़ाइन की टीम को इतना कम काम भी नहीं करना कि जो डिज़ाइन टीम है इनफ डिटेल स्पेसिफिकेशंस ही प्रोड्यूस ना कर सकें उस डिटेल डिज़ाइन से जो आगे हेल्प आउट हो सके. सो इन शॉर्ट यू कैन से दैट design team should not do much, it look like a code, or design team should not do a little work which needs or which is essential to complete a detailed design. So these are the two basic challenges. You should not do too much or not do too little for the design team. These are the two most broader categories of design challenges which must be considered in the design phase. So here are some characteristics of good design and bad design. So students, here I will provide you the some differences between the good design and the bad design. What is the good design and the bad design? And I hope so all of the students now you are well aware about the design. As we discussed earlier, what is the design, and we also discussed the two levels of design, which we also discussed in very detail over our first three lectures of our this course, like architectural design and detailed design. Now here I am discussing about the general term of design. So what are the some good characteristics of good design and the bad design? So let's discuss the good versus bad design. So you must consider some general aspects, like good design must meet all the technical requirements, while the bad design meets only some technical requirements. Bad design does not meet all the technical requirements, while the good design meet all technical requirements. In other words, we also can say that like change in one part of the system does not always require a change in another part of the system, which carries to the good design. So what does it mean? अगर हम अपने सॉफ्टवेयर के एक पार्ट के अंदर डिज़ाइन में कुछ चेंजिंग करें, तो उस चेंजिंग के अगेंस्ट हमें अपने सॉफ्टवेयर के उस डिज़ाइन के दूसरे पार्ट्स में भी चेंजिंग ना करें. सो बेसिकली ये एक निशानी है अच्छे गुड डिज़ाइन की. और बैड डिज़ाइन की निशानी क्या है कि अगर आप एक सॉफ्टवेयर के डिज़ाइन में एक मॉड्यूल में चेंज करें तो उस चेंज के साथ आपको दूसरे सभी मॉड्यूल्स में भी चेंजेस करनी पड़े, सो एक्चुअली इट लीड्स टू अ बैड डिज़ाइन. So in other words, good design you can say that works all the time, while the bad design works initially but stops working after a short time. And in the second, you can see that the good design gives us a piece of exactly one logic, while the bad design has to be duplicated. Like good design is gives or depicts actually exactly the same logic, while the bad design logic has to be duplicated at different places in the design phase. So जो हमारे पास गुड डिज़ाइन है उसके लिए हमें लिटिल मेंटेनेंस रिक्वायर्ड है, जबकि बैड डिज़ाइन के लिए हमें बहुत ज़्यादा मेंटेनेंस रिक्वायर्ड है. सो एज वी डिस्कस्ड इन आवर पॉइंट फर्स्ट कि गुड डिज़ाइन के अंदर अगर हमारे पास एक पार्ट में चेंज करें तो हम अदर पार्ट में चेंजिंग नहीं करनी पड़ती, विच अल्टीमेटली लीड्स टू लिटिल और नो मेंटेनेंस, वाइल इन द बैड डिज़ाइन वेयर changing in the one part requires changing in the all other parts as well, which ultimately requires frequent maintenance. So we can say that the good design requires little or no maintenance, while the bad design requires frequent maintenance. And the next one is the logic is more near in the data, it operates on in the good design, while in the bad design it can't remember where all the implicit linked changes have to take place. Like you can say that a good design is more safe or a bad design poses a hazard to users. And the next one is the system can be extended with change in only one place, कि जो हमारा सिस्टम है हम उसको एग्जैक्टली वन प्लेस पे चेंज करके एक्सटेंड भी कर सकते हैं, वाइल ऑन द अदर हैंड we can't do this. So good design is more simpler and the bad design is more complex as well. So and you can also say that good design creates no ethical dilemma, while the bad design raises different ethical questions as well. And the good design meets cost requirements, while the bad design cost more than it should be. So these are the different differences between the good design and the bad design. So you can also go through from the different, there are other many differences are available between the good design and the bad design as well. So here are some brief discussion about the good design and the bad design. I hope so you will be understand the main differences between the good design and the bad design. Now here there are different levels of software architecture. As we discussed earlier, there are design phase is further divided into two different levels. First level we call the architectural design, and the next level which we call the detailed design. Architectural design we also call it a high level design, and the detailed design we also call it a low level design. So as we discussed earlier, architectural design is basically concerned with the selection of different architectural elements, their interactions and constraints on those elements, etc., while the design is specifically concerned with the modularization. So modularization we can achieve through encapsulation and information hiding. If you remember, basically abstraction external to the system which we call the architecture, which we achieve through different three types of decomposition: layer based, tree based, and the subsystem based, while abstraction external to internal to the system which we call the modularization, actually it concerned about the detailed design which we achieve the modularization through information hiding and encapsulation as well. So basically architecture is concerned with issues which actually beyond the algorithm and data structure of the computation. And you can also say that detail design is actually concerned with the modularization and the detailed interface of the design elements, like their algorithms, procedures, different data types. All of these are concerned with the detailed design. So in short, architectural design is the high level design and detailed design is a low level design. About these two levels of software design are already discussed in very detail in our first three lectures. So I hope so you are well aware about these two terms of design phase, architectural design and the detail design. So students, in this slide here I give you the some difference between the architecture design and the detail design. So as we discussed earlier, architectural is basically concerned with the architectural elements, while design is concerned with the modularization, which we actually achieve through the information hiding and the encapsulation. Architecture gives us the skeleton of the system, not not the detail internal details of the system, how the system will perform its different functions. It architectural only give us the overall structure, main modules, and their connections, and the architecture only addresses the non-functional requirements. As we discussed earlier, non-functional requirements are quality requirements which must meet or fulfilled by the system, like reliability, availability, maintainability. There are different abilities are available, performances, maintainability, and these non-functional requirements are hard to measure and hard to achieve. These non-functional requirements are basically addressed in this architectural design, while detailed design is more low-level design, which actually gives us the internal structure of main modules, and it also give us the implementation level little bit details of how the our detailed design will be implemented, not the code, but will be give us the enough detail to be implemented in the programming language. So basically detailed design is the inner structure of main modules, how the system will actually communicate with one module to another module. It's all about the detailed design. So students, here we see the difference between the architecture design and the detailed design. So in short, you can say that basically all architecture is design, not all design is architecture. So what does it mean? So as if you remember, requirement analysis and gathering phase is the first phase of SDLC, which is actually our problem domain, in which we must say what the system will do. And the next phase is the design phase, where we discussed how the system will perform its different functions. And then this design phase is further divided into two phases: architectural design and the detailed design. In the architectural design, we only develop the skeleton of the system from the given SRS or systems requirement specification document, which is actually input from the analysis phase to the design phase. From this SRS document, we develop a skeleton of the system in which we address different non-functional requirements, while in the detailed design we see the internal working. So all architecture leads to design, but not all design will be helpful to reverse back the architecture. So you can say that the architectural basically focus on the stakeholders, not on the technology, and while the detailed design is more focused on the implementation level and the technology details, like what kind of middlewares, what kind of database design will be used. So here are the differences between the architecture design and the detailed design. Architecture design is concerned about the stakeholders. Basically, stakeholders are someone who are directly or indirectly affected by the system. Like in as we discussed earlier, the different kind of stakeholders for university management system. So students, and the last point is architecture basically does not describe the complete characteristics of components. It actually gives us the skeleton or blueprint of the about the system from the SRS document. And this architecture only comprises of the different boxes and lines, while the detailed design comprises of the complete characteristics of components, how the inner structure, how the inner modules will communicate with one another. So till here students, we discuss the main differences between the architecture and the detailed design. I hope so till here you are well aware about the architectural design and the detailed design. So in this diagram you can see that the first, after the requirement analysis and requirements analysis and gathering phase, from where we get the system requirement specification document, which we also call as SRS document, is actually input to the design phase. And in the design phase, first type of design is architectural design, which actually gives us the skeleton or blueprint of the system. From this SRS document, we build over the architecture with the help of some box and line diagrams, like by using different modeling languages, like we see earlier, unified modeling language, which actually help us to develop our architecture. After the architectural design, this architectural based notations or architectural based modeling help us to further goes into detailed design, where we discuss how the inner structure of the main modules will communicate with each other. And in the detailed design, we looked to more implementation level details. After the detailed design is complete, the phase 2 of SDLC, which comprises of basically two design activities, architectural design and the detailed design. These design phases are complete, and then we move towards the implementation level, where we implement our system into फाइनल कोड. सो बेसिकली ये डायग्राम हमें ये बता रही है कि हमारे पास सबसे पहले एस आर एस डॉक्यूमेंट से हम आर्किटेक्चर बनाते हैं, डिफरेंट बॉक्सेस एंड लाइन्स से डिफरेंट नोटेशंस को यूज़ करते हुए, जैसे हमने यू एम एल को यूज़ किया. फिर उस आर्किटेक्चर से हम डिटेल डिज़ाइन की तरफ जाते हैं. उस डिटेल डिज़ाइन के अंदर हम देखते हैं कि इनर स्ट्रक्चर क्या होगा, हम मॉडुलराइजेशन को थ्रू इनकैप्सुलेशन और इन्फॉर्मेशन हाइडिंग को अचीव कैसे करेंगे, हम उधर डिटेल डिज़ाइन सिस्टम की ऐड करेंगे. उसके बाद हम इम्प्लीमेंटेशन लेवल पे थ्रू डिटेल डिज़ाइन हम इम्प्लीमेंट करेंगे अपने सिस्टम को इन सम फाइनल कोड. सो बेसिकली इस डायग्राम के अंदर ये बताया जा रहा है, आर्किटेक्चर ऑलवेज कम्स earlier than design, and design is always produced from the architecture. So it's not possible to produce a good design from the architecture. Always design is produced from the architecture. So here, let's see another difference between the design and architecture. Here you can see that basically architecture addresses the non-functional requirements of the system. What kind of non-functional requirements? Like different kind of utilities, mean like reliability, availability, portability, maintainability, adaptability. All of these type of non-functional requirements of the system are basically addressed in the architectural design, while the functional requirements what the system will perform basically addressed in the detailed design phase. So as we discussed earlier, design phase is divided into two broader categories of architectural design and the detailed design. Architectural design is concerned with the non-functional requirements, and the detailed design is concerned with the functional requirements of the system. Let's discuss the functional and non-functional requirements. Let's consider, we take the baggage handling system. So what will be the functional requirement of baggage handling system? For example, I say the system shall handle up to 20 bags per minute. It's an example of functional requirement. So what are the non-functional requirement? Like for baggage handling system in any airport, like efficiency, which we see two different things, performance and space. Like for the performance perspective, how many number of bags per minute will be handled by this baggage handling system? It is basically a non-functional requirements. Like there can be other requirements like space requirement, physical size of system, amount of memory and power consumption needed to carry the space by the this baggage handling system. So in non-functional requirements are basically the quality requirements of the system, and functional requirements are basically the services provided by the system. Architectural design addresses the non-functional requirements, and the detailed design addresses the specific functional requirements. So till here we discuss that very comprehensively about the detailed design and the architectural design, which are two broader categories of design phase. So here a little bit of motivation of architectural design. So students, here my question from all of you is, can we directly start with the detailed design? From our previous discussion, we can conclude that definitely or most likely no. For large scale system, why, as I said earlier, we must first develop an skeleton or blueprint of the system from the SRS document, which we call the architectural design. And architectural design help us to achieve non-functional requirements, as we see earlier slide. So why I said no, for like, let's consider an example to build a house. There are many styles available, like you can build your house like in a Victorian shape, like colonial, Cape Cod, California rank. Depending on the system specification, style has to be chosen. So there are different architectures according to your specification. So from where the specification will come? From the SRS document, which is the output of requirement analysis and gathering phase. This SRS specification will ultimately helps us in the design phase, where is the architecture design is the first activity of design phase. With the help of this architectural design, we will get the skeleton or blueprint of the system. So from this slide, we can conclude that architectural design is very important before we move towards the detailed design. We can't move directly towards a detailed design by skipping the architectural design. If in small projects we move directly or jump to the detailed design by skipping the architectural design, ultimately it will be bad for our project. It may be a cause of failure. You will also see a different design errors in some real world case study in the last of this lecture, so that you can get better idea. We can't move directly from architectural can't move directly to design phase, or we can't skip the architectural design. We see in the later part of this lecture. So students, till here whatever we discuss, my question to you is, where does actually architecture design comes from? तो अब तक हमने जितनी भी डिस्कशन की, जो हमारे पास आर्किटेक्चरल डिज़ाइन है, ये हमारे पास कहाँ से आता है? सो टिल हेयर हमने देखा कि आर्किटेक्चरल डिज़ाइन आफ्टर रिक्वायरमेंट एंड एनालिसिस फेज से जो एसआरएस डॉक्यूमेंट हमें आउटपुट में मिला, उस एसआरएस डॉक्यूमेंट को एज एन इनपुट करते हैं डिज़ाइन फेज के अंदर. एंड नाउ from this SRS document, we actually build our architectural design, which we also call the skeleton or blueprint of the system. So this architectural design shows or represents, which actually derives from the system requirement from the analysis model. So what does it mean? कि जो आर्किटेक्चरल डिज़ाइन है ये हमारे पास एस आर एस डॉक्यूमेंट से आता है, जो कि हमारे पास रिक्वायरमेंट एनालिसिस मॉडल से की आउटपुट है एस आर एस डॉक्यूमेंट. और उस एस आर एस डॉक्यूमेंट की हेल्प से हम एक डिफरेंट मॉडलिंग लैंग्वेजेस लाइक यू एम एल, लाइक अदर बॉक्स लाइन एंड बॉक्सेस डायग्राम्स की हेल्प से अपने सिस्टम का आर्किटेक्चर, स्केल्टन और ब्लूप्रिंट को डेवलप करते हैं. किसके अंदर? आर्किटेक्चरल डिज़ाइन के अंदर. सो फाइनली वी कैन से दैट architectural design derive from the software or system requirement specification document, which we call the SRS document, which is actually the output of requirement analysis and gathering phase. So now my question to you student is, who is responsible for developing the architectural design? Who is responsible for developing the architectural design? You must think who is responsible. So now in further slides I will ask you different questions to assess how much you understand about the design and the architecture. So further slides are more question oriented. Till here what we studied. In coming slides I will ask you different questions to assess your understanding. So here my question to all of you is, how is responsible for developing the architecture design? So so basically software architects and designers are involved in this design process. They actually map the soft SRS requirements into architectural design, and then during the translation process they apply various design strategies to divide and conquer the complexities of an application domain and resolve the software architecture. So students, what does it mean? आर्किटेक्चरल डिज़ाइन कौन बनाता है? हमारे पास जो एसआरएस डॉक्यूमेंट है, जो हमारे पास प्रॉब्लम डोमेन थी, रिक्वायरमेंट एनालिसिस एंड गैदरिंग की, उसको मैप किया जाता है सॉल्यूशन डोमेन के ऊपर, जिस जो कि है डिज़ाइन फेज़, उसको हम सॉल्यूशन डोमेन भी बोलते हैं। उसको मैप करके हम अपनी एसआरएस रिक्वायरमेंट्स को कन्वर्ट करते हैं डिज़ाइन फेज़ के ऊपर के फर्स्ट एक्टिविटी पे, जिसको आर्किटेक्चरल डिज़ाइन का नाम दिया गया है। और आर्किटेक्चरल डिज़ाइन कौन बनाता है? दीज आर मेड बाय द सॉफ्टवेयर आर्किटेक्ट्स, नॉट द डिटेल डिज़ाइनर. Architects are the different than the detail designers. So basically there are two kind of personals in the design phase. First one, the architecture, and second is the detail design. Architects are the responsible to build the software architects, while the designers are responsible to build the inner functionalities of the system. So students, now my question to you is, why software architectural design is so important? So every student will have different answer. All of you must have to justify this statement, why software architectural design is so important. All of these kind of questions are important from exam point of view. If you noticed from previous 3 to 4 slides, I am asking you these kind of different questions to assess your understanding about the lecture. So now students, my question to you is, all of you is, why software architectural design is so important? So students, everyone will have different answers. All of your answers must be justified with proper arguments. So on my behalf, I will say that there are several reasons in my point of view why a software architectural design is too much important. You can say that a poor design may result in a deficient product, like it does not meet system requirement, or it not adapted to future requirement changings, not reusable, or it not exhibits or unpredictable behavior, or it performs badly. With proper planning in the architectural design stage, software production may be very inefficient in terms of time and cost. So these are the reasons in my point of view for a poor design. Like in contrast, for a good design in a software actually reduces the risks associated with the production of any software, which ultimately helps the development team to work together in an orderly fashion, which makes the system more traceable from implementation phase and the testing phase, which ultimately leads to software product that have the higher quality attributes. So in my point of view, these are the different uh, suggestions in my point of view for a poor design and a good design. For a poor design, a deficient product, what kind of it can be lead to? Like if a design is not good, due to following reasons, like it not meet system requirements, like it not adaptive to change in future requirements, this design is not reusable, it's unpredictable behavior, or this performs badly. All of these are factors which actually cause for the poor design. Students, you can also add some more points from your point of view, but you have to properly justify it why these factors are important for a software architecture. I hope so students, you understand why software architectural design is so important. So students, now we will discuss when is software design conducted. Software design कब conduct किया जाता है? If you see this diagram from the most left side, the analysis phase, which is basically the requirement analysis and gathering phase, which is the first phase of SDLC. The output of first SDLC phase is SRS document, which we call a system requirement specification document. This system requirement specification document is the output of first phase, and which leads to the as input to the design phase. And the design phase, in the dashed line boxes, you can see that design phase is further divided into architecture design and the detail design. And we very comprehensively look into the architecture and detail design as well. And this SRS document is leads as input to the design phase, and this design phase actually gives us the SDD document, or software detail design document, which ultimately help us in the implementation level. So you can see that the output of requirement analysis phase is the SRS document, and the output of design phase is SDD, which we call a software detail design or document, which actually is the output of design phase. So here you can clearly see that the analysis or requirement phase is the problem domain, where we discuss what the system will do, and we specify it in the SRS document. And in the design phase, you can see that basically in the dashed line, it is over the solution domain, where we actually tells how the system will perform different functions, and we all these different functionalities in terms of functional requirements and in the non-functional requirements. As we discussed earlier, architectural addresses the non-functional requirements, and functional requirements are addressed by the detailed design. All of these functional and non-functional oriented design requirements are described in the software detail design document, which we also call the SDD, which ultimately is the output of design phase and act as an input for the implementation phase to final develop our system. So students, as we see, software design is early phase of SDLC. During this phase, basically designers model the system and assess its quality, so that improvements may be made before the system goes into the production phase. So in this diagram, we comprehensively see how requirement analysis and gathering phase tells us what the system will do, and the design phase in the dashed line boxes tells us how the system will perform its functions, where we see how architectural design addresses the non-functional requirements and how detailed design addresses the functional requirements. And software detail design document or software design document is the output of design phase. The requirement phase is the problem domain, and the design phase is the solution domain. Problem domain tells us what the system will do, and the solution domain tells us how the system will perform its functions. So till here we discuss the problem domain and the solution domain. So I hope so you very well understand this diagram, as it is self-explanatory, and we already discussed all of these terms repeatedly in our previous slides and previous lectures as well. So students, what is the outcome of software architectural design? So it's my question to all of you कि सॉफ्टवेयर आर्किटेक्चरल डिज़ाइन की हमारे पास आउटपुट क्या होती है. Simply, software architecture represents the overall structure of what the software we are going to build. So in short, we can say that it not only describe the elements and connector between elements. Architectural design also addresses the constraints and runtime behavior as well. So ultimately, the developers must know what and how the system design should be implemented. कि आर्किटेक्चरल डिज़ाइन से आगे जो हमारे पास डिज़ाइन की टीम है, उनको ये पता हो कि उन्होंने आगे डिटेल डिज़ाइन को कैसे फर्दर मोर डिटेल्स में इम्प्लीमेंट करना है. तो इनफ डिटेल्स होनी चाहिए between the elements and the connectors, and it also includes the constraints of the system and their runtime behavior as well. So it is the overall outcome or output of the software architectural design. So till here students, I all our last 7 to 8 slides are more question answer oriented slides. So in these kind of questions I will be more interested in exams. That's why I am asking these kind of questions to prepare yourself from exam point of view. You don't need to remember all these slides, you just need to clear your concepts. So in this diagram, students, you can see that the software architecture in context. So till here we discuss the software design term very briefly, where we see different kind of designs. From software design we further goes into the detail architectural design and the detailed design. If we discuss the overall purpose of that design is, so till here I am if you see in the most right bottom part of this slide, you can see the legend, the feed forward arrow, the feedback arrow, and the development task is represented by the rounded rectangle. You can see the most left side of this development task is the basically the problem domain, which we call the requirement analysis phase, from where the requirement actually input to the software architectural design, and then these kind of modifications is input to the hardware architecture, from where we also get the feedback from the hardware architecture. And now after the software architecture and design gets two-way inputs from the domain and analysis phase to the design phase, it ultimately feed its software architecture into detailed design. And then from this detailed design we more moves towards the coding phase and the to so on to the testing phase. So in this diagram is also self-explanatory. So ultimately you can say that software design is an iterative process which keeps on improving as we understand problem domain, as we design more. It is a complicated process, so therefore it is needed to be modeled similar to an architect blueprint. So architectural design of the software is the highest level of software design, from which detailed level of design emerge as we further grill the requirements to develop an architectural model. So what is model? Basically a model is an abstraction of underlying problem. Software design, we can build or model the software design by using different modeling languages. We already discussed unified modeling language very briefly and comprehensively with the help of some real world case study in our last slide as well. So in this diagram we see how the software architecture communicates three-way from problem domain to the solution domain, and we also see the hardware level aspect of design as well, where we also discussed what kind of middlewares will be used, what kind of database design will be used. All of these aspects are basically addressed in the software architecture. So here we see the context of software architecture in this diagram. So we can conclude that basically the goal of our design is to build a model that meets all the customer requirements, which ultimately leads to successful implementation. As the system continues to grow, like in scale, complexity, distribution, their proper design become more complex, or extremely complex, or it becomes the more importance in software production. So you can say that any software, regardless of its application domain, should have an overall architectural design that guides its construction and development. So ultimately, the success of a software product or system mostly or largely depends on the architectural design. सो स्टूडेंट्स, किसी भी सॉफ्टवेयर के प्रोडक्ट की जो सक्सेस है, इस डायग्राम में हमने ये देखा कि वो किसके ऊपर डिपेंड कर रही है, या आर्किटेक्चरल डिज़ाइन के ऊपर। हाउ हमने देखा कि आर्किटेक्चरल डिज़ाइन इज़ बेसिकली द मोस्ट कंटेक्चुअल डायग्राम ऑफ डिज़ाइन फेज। हाउ आपने देखा कि आर्किटेक्चरल लेवल डायग्राम से ही हम अपने प्रॉब्लम डोमेन को मैप करते हैं सोल्यूशन डोमेन पे। एक्चुअली आर्किटेक्चरल डिज़ाइन वो फेज़ है जहाँ पर एक्चुअली हमारी जो रियल वर्ल्ड एसआरएस डॉक्यूमेंट की रिक्वायरमेंट्स हैं उनको मैप करते हैं विद द हेल्प ऑफ सम रियल वर्ल्ड मॉडलिंग लैंग्वेज, जो हमें देता है आर्किटेक्चरल डिज़ाइन। और उस आर्किटेक्चरल डिज़ाइन से हम अपने हार्डवेयर के लेवल की आर्किटेक्चर को भी डिटेल में डिस्कस करते हैं। नाउ बेस्ड ऑन द real world requirements and the hardware architecture as well, From these two things, software architecture actually leads toward the detailed design. So we can say that the software architecture is the most important thing in the success of a software product or system. As you can see that the system largely depends on the success of its architectural design. As you can see that the success of architectural design is playing a vital role in the success of software product in this slide as well. So students, I hope so you are well understand this diagram, as all the arrows are labeled, the development tasks are also labeled. So this diagram is well understand, and I hope so this detailed discussion will help you a lot. So now students, there is some interesting task. So here is a real world case study about the design. So students, this is your homework to do. So there is a real world case study which is the name of Ariane 5 flight 501. About Ariane 5 flight 501, you can get the very details from the internet. You have to self study this Ariane 5 flight 501 from the internet on your behalf. So this project actually fails due to design errors contained in this software. So here below is a given YouTube link. Basically in this YouTube link, it actually shows the Ariane 5 explosion. You can see how the Ariane 5 explosion causes due to design errors in it. So students, you have to self study about what design error caused for the failure in Ariane 5 project. So I will give you a 1 to 3 line little bit intro about the Ariane 5, actually what it is. Basically Ariane 5 is a spacecraft which will launch on the median flight of the Ariane 5 rocket, which called the flight 501 name, and it subsequently lost its direction when the rocket failed to achieve the orbit. It was launched in the 4 June 1996, which ultimately ended in failure due to an error in software design, which actually caused by some internal level error, which they call the integer overflow. So this Ariane 5 failure, also known as the most famous and expensive software bugs, which causes due to the error of design. So the failure ultimately resulted in a loss of more than 370 million US dollar. So students, आपको इस केस स्टडी को एरियन 5 फ्लाइट 501 को इंटरनेट से सर्च करके इसकी केस स्टडी को आपने रीड करना है विद रिस्पेक्ट टू डिज़ाइन एरर्स. यू डोंट नीड टू सी अदर डिटेल्स. आपको अदर भी कोई भी टेक्निकलिटीज़ को देखने की ज़रूरत नहीं है. एज अवर सब्जेक्ट इज़ रिलेटेड टू सॉफ्टवेयर डिज़ाइन एंड आर्किटेक्चर, you have to only see the design related error in this Ariane flight 501. So students, all of you have to go through from this case study, and you need to discuss the Ariane 5 flight 501 with respect to design errors contained in this project as well. And this is the individual activity. All of you students must discuss, all of you students must see this case study. It is important from exam point of view. I will not ask the theoretical questions. This kind of case studies will be provided to you, and you give us the different reasons what kind of design errors contain in it. So this kind of real world case study will be more focusing in this subject as well. So students, till here what we discussed, till here our lecture is ended. So till here we see the different architectural design, we see architectural design, and we also who develop the architectural design, and then we see the very briefly software design. We'd see the difference between the problem domain and the solution domain, and we also see how the architecture is different from the detailed design, and then with the different challenges being faced in the design phase. And we discuss different good characteristics between the good design and the bad design. After it, we also discuss different levels, and we also see their differences as well, architectural and detail design, and we also see how architecture gives us the non-functional, and design detail design gives us the functional requirements. After it, we also see the motivation of architectural design, in which I ask questions from students: how can we move directly from architectural to detail design? So the answer is no, and we also discussed why we can't move or can't skip the architectural phase. And then I asked different questions from students, like where does the architectural design come from, like who is responsible for developing the architecture design, like why is software architecture design so important, like when is software design conducted, where we see how the problem domain, where we see the what the system will do, and how the design phase will perform its functions, and we see how the problem domain will map to the solution domain, where we see how the SRS document is input to the design phase, and how the SDD document, which we call the software design document, will be output of the design phase. We also discussed it through diagram as well. And then we see ultimately what is the outcome of software architectural design. And then we see the software architecture in context in the last one slide, where we see how software architecture is so important, because it directly maps the requirements, because it actually directly maps the requirements to some boxes and line based diagrams through different modeling languages, like we discussed unified modeling language in our earlier lecture. And we also see the hardware architecture aspects as well, which ultimately leads towards the detailed design implementation as well. And at the end, from all of previous slide, I want to judge your capability about the how much you understand about the design. I am giving you the a real world case study, which is the Ariane 5 flight 501, which actually fails due to the design errors contains in it. And in this YouTube link, you can see the video of Ariane 5 explosion, how it actually becomes fail, and you can easily get the details about the Ariane 5 flight 501 on the internet. Lot of material is available. And now all of you students, it's your individual activity. You have to self study about Ariane 5 flight 501, and you need to discuss what kind of design errors causes for this project to be fail. And it's all of its individual activity. All of you students must discuss or must go through the design aspects of Ariane 5 flight, which causes its failure. So it's your individual activity, and all of you students must go through from it. So till here, our lecture number 8 is ended.